Welcome to the session. So in this video, we are going to discuss solution to differential equations using Laplace transform. So here you will see one problem. A system is described by the differential equation. So double derivative of y of t plus 6 derivative of y of t plus 8 y of t equals to derivative of x of t plus x of t. And initial conditions are derivative of y of 0 equals to 3, y of 0 equals to 1 and x of t is u of t. Find the transfer function of system and output response. So there are two parts in the question. So first one is find the transfer function. So this is part number 1, and the second one is find the output response of a system. So here differential equation is given. So we need to convert into a simple S domain form. So for that purpose, so we use the differentiation property in time domain. So now we recall the differentiation property in time domain. It is already explained and the video is also uploaded. So if you want to more information about the differentiation property in time domain, you please watch the video which was uploaded. So if the signal is y of t, so then its Laplace transform becomes y of s. Suppose we will take the derivative of y of t, d by dt of y of t, then the Laplace transform is s into y of s minus y of 0. So double derivative d square by dt square y of t, then Laplace transform becomes s square y of s minus s y of 0 minus t by dt of y of 0. So we use these relations to convert the given differential equation into simple algebraic notation. Suppose here we are taking y of t. Suppose the signal is given x of t, then we use x of t is equal to x of s, then derivative of x of t is equal to s into x of s minus x of 0. We replace y with x. And now we will start the solution of this problem. So we convert the differential equation into S domain. So using the property, differentiation property in time domain. So first term is double derivative of y of t. So we write it as s square y of s minus s y of 0 minus d by dt of y of 0. So this is first term. Then the second term is plus 6 into d by dt of y of t. So we write as s y of s minus y of 0 plus 8 y of s equals to derivative of x of t. So this is s into x of s minus x of 0 plus x of t. X of t Laplace transform will be x of s. Now observe the expression s square y of s and y of 0 is there here, the derivative of y of 0 and all this. So as a first part we will try to find the transfer function. So transfer function definition says that transfer function definition is Laplace transform of output by Laplace transform of input at zero initial condition. At zero initial conditions. All the initial conditions we consider as zeros. So in the above equation, so we have some initial condition y of 0 and d by dt of y of 0, and here y of 0 and x of 0. Okay. So these are all initial conditions. So to find the transfer function, we neglect all initial conditions. To find transfer function, we neglect all initial conditions. So that is y of 0 equals to 0 and derivative of y of 0 equals to 0 and x of 0 is also a 0. Now substitute these all the conditions in the expression. So then we obtain s square y of s plus 6 s into y of s plus 8 y of s equals to s into x of s plus x of s. Now from the left side we take y of s is common, y of s into s square plus 6s plus 8 equals to, so here we take x of s is common and then it becomes s plus 1. Okay. So now we take the ratio of output y of s to input x of s, so that gives you the transfer function of a differential equation. So that is y of s by x of s equals to s plus 1 by s square plus 6s plus 8. So this is the transfer function of differential equation. Transfer function of differential equation. This is the first part of the solution. Now we will move to the second part to find the response of a system. To find response of a system. So response of system is nothing but y of t. So we need to find the response in time domain. So for that purpose, we consider some initial conditions given in the problem. So that is, so y of 0 equals to 1, dy of 0 by dt equals to 3, and one more condition given as x of t is equal to u of t. So from this we write the corresponding Laplace domain x of s. The Laplace transform of x of t is x of s. Then the Laplace transform of this u of t becomes 1 by s. So from this we can find the initial condition x of 0. So we know that, so this is unit step signal. So this unit step signal has magnitude 1 from 0 to infinity, and before that on negative axis its value is 0. Okay. Now the moment before this 0, so we can call it as 0 minus, right? So here we can represent x of 0 minus, the value at 0 minus is equal to 0, or this x of 0 minus we call it as initial condition, that we can also represent as x of 0, so that's value is equal to 0. So from this, so we can write x of 0 minus or x of 0 is equal to 0. So now these three initial conditions, so we'll try to substitute in the equation number 1. So in the first one we call it as, we just name this equation as 1. Now substitute these initial conditions in that expression. So we'll get s square y of s minus s minus 3. So this is first term, plus 6 into s y of s, and the initial condition is 1, y of 0 is equal to 1, plus 8 y of s equals to s into x of s minus x of 0, its value is 0, plus x of s. So now we write the terms separately. All the we rearrange this equation as s square y of s plus 6 s into y of s plus 8 y of s, and then minus s minus 3, and 6 into minus 1, so that is minus 6, equals to s into x of s plus x of s. Now further simplify this. So here we take y of s is common, y of s in the first three terms. So y of s into s square plus 6s plus 8 minus s minus 9 equals to s into x of s plus x of s. Now simplify. So y of s into s square plus 6s plus 8 equals to s into, so x of s value is 1 by s, so into 1 by s plus 1 by s. Now we will shift this minus s minus 9 to the right, so it becomes plus s plus 9. So that is y of s into s square plus 6s plus 8 equals to, now the right half expression becomes, so we can simplify this and we can write directly s square plus 10s plus 1 divided by s. Now we need the expression only for y of s. Then we shift this term to the right side. So then we'll get s square plus 10s plus 1 divided by s into s square plus 6s plus 8. So this can also be written as s square plus 10s plus 1 divided by s into. So we convert this quadratic equation into simple poles form. So then we will get s plus 2 into s plus 4. So this is y of s. Now using partial fraction expansion, we write s square plus 10s plus 1 divided by s into s plus 2 into s plus 4 equals to a by s plus b by s plus 2 plus c by s plus 4. Now we need to find a, b, c. Okay. So for that purpose we take LCM on right side and we write the expression s square plus 10s plus 1 divided by s into s plus 2 into s plus 4 equals to, so we take the LCM of this right part, so that becomes s into s plus 2 s plus 4. So numerator is a into s plus 2 s plus 4 plus b into s into s plus 4 plus c into s s plus. Now the numerator is different and denominator is same on both sides, so we'll cancel this denominator. So this expression becomes s square plus 10s plus 1 equals to a into s plus 2 s plus 4 plus bs s plus 4 plus cs s plus 2. Now we'll try to find a value, b value, c value. So to find a, b, c, what we do is we put s is equal to 0 to find a, and s is equal to minus 2 to find b, s is equal to minus 4 to find c. So put s is equal to 0 in this equation, in equation 2, let's say for our convenience. So put s is equal to 0 in equation 2, we'll get a value. So a is equal to 1 by 8. Similarly, put s is equal to minus 2, so we'll get b equals to 15 by, sorry, 15 by 4. Put s is equal to minus 4. C value, will get C value minus 23 by 8. Now substitute these values in the place of A, B, C, and then apply the inverse Laplace transform. So y of s equals to a 1 by 8 by s plus b 15 by 4 s plus 2 minus c is minus 23 by 8, so that is s plus. Now this is y of s, but we need the time response of a system. So we need to apply the inverse Laplace transform on both sides. So apply inverse Laplace transform on both sides. So Laplace inverse of y of s equals to, so 1 by 8 is constant term, we write outside, then Laplace inverse of 1 by s plus 15 by 4 is the constant, Laplace inverse of 1 by s plus 2 minus 23 by 8 Laplace inverse of 1 by s plus 4. We know the formulas. Laplace inverse of 1 by s equals to u of t. Laplace inverse of 1 by s plus a equals to e power minus at. Okay. Now the Laplace inverse of y of s is y of t, which gives the time domain signal, 1 by 8. 1 by Laplace inverse of 1 by s is u of t plus 15 by 4 Laplace inverse of 1 by s plus 2. It is in the form of 1 by s plus a, so that we write e power minus at. Minus, in the a position we have 2 minus 2t, and to represent right sided signal or causal signal, so we use u of t minus 23 by 8 e power minus 4t u of t. So this is the response of a system for the given differential equation. So this is a time domain signal which represents the response for the given conditions.